Thanks. Uh, Hey, so we'll be starting with our opening keynote speaker, Mr. Ian Lewis. He'll be talking on the topic, the Kubernetes API and the next-gen automation tools. This talk will inspire you to leverage cluster-level APIs and distributed system design patterns to build next-gen automation tools. Ian is a developer advocate for Google Cloud Platform. He's based in Tokyo, Japan. He's the co-founder of PyCon Japan, which is the largest Python community conference in Japan. He programs in Go and Python. He loves learning systems, knows working, and mostly spends time writing and deploying web apps to Kubernetes. Please give big hands for Ian.
Good? You're happy. Like, what'd you have for breakfast? Toast. Ah, okay. Well, I'll keep that in mind for next time. I had lots of coffee this morning because I was a little bit tired. But today I'm going to be talking about Kubernetes and the next generation of automation tools. This is basically like how to develop applications that can help you automate your job or automate DevOps so that you have less problems as you're, to keep your applications up and running. So my name's Ian Lewis. I'm a developer advocate at Google Cloud Platform, or at Google and the Google Cloud Platform team. I'm based in Tokyo, Japan. So this is my first time in India, so I'm really excited to be here. You can follow me on Twitter if you like, at Ian M. Lewis. But enough about myself. I'm here mostly to talk about Kubernetes and how to build tools on top of Kubernetes, but you can kind of abstract some of these ideas to essentially cloud or container orchestration systems. So any type of orchestration system, provided it has features that are similar to Kubernetes, can utilize a lot of these concepts. So what is Kubernetes? So Kubernetes is a platform for building distributed systems. So what does that kind of mean? So Kubernetes is a kind of a way of deploying applications and then keeping them up and running, and then helping to automate how to tie those applications together so that they can access each other, so that you can access them via a simple endpoint or things like that. So it's a toolkit consisting of a bunch of different features that you can combine together in order to deploy applications. So we like to think of Kubernetes as kind of like a core or a kind of a kernel in some sense. So you'll hear people like Mesos talk about DCOS or something like that, and Kubernetes is very similar in that sense. In that it's like the Linux kernel. It's a way to deploy and schedule applications to physical resources, and then allow you to build systems on top of that. So a lot of people like to build things like Deis or OpenShift, these type of like more platform as a service things, and Kubernetes is a little bit more low level. It allows you to kind of deploy the applications and schedule them and keep them running. So essentially your app and your platform can be kind of built on top of Kubernetes in order to utilize a lot of these features. Okay, so what is Kubernetes? And I just want to like go through what Kubernetes is a little bit before I start talking about the automation tools and how to build those type of tools on top of Kubernetes, just so that we're all on the same page. So how many people know or have used Docker? I'm assuming that a lot of you have, yeah. So many of you have actually touched or played with Kubernetes before. Okay, so good number of you. So just to get everybody on the same page, so in the past, what we've done is we've connected to all of our and managed all of our servers by like logging in via SSH and like kind of running something like Puppet or Ansible or something like that in order to configure these machines or deploy applications. And this is like very unwieldy because you're basically, you would have to, run this kind of like, configuration management system to across all of your servers. So like all of these machines would have this script running on it, and you would have to do this either periodically or whenever some sort of code changes. But when something happens within your cluster, you want to change some sort of configuration, you've got to run this whole script again. And this is can be kind of unwieldy when you're dealing with thousands or hundreds of servers. So when you're dealing with a container cluster, you just deal with something like an API, and you let the container cluster deal with a lot of the configuration management for you. So essentially what this means is you have an API that you can tell the cluster what you want, and then the cluster will basically do that for you. So you could say, I want to deploy Nginx, and I want to have 1,000 or I want to have 100 or 5 or 10 even replicas of Nginx running, and the cluster will essentially just do that for you. You won't have to write scripts to actually install Nginx and run it. So Kubernetes from a very high level. So let's actually do a little demo of how Kubernetes might work from a user perspective. So let me make this a little bit bigger. So generally what you do to use Kubernetes is you use something called a kubecontrol command, which is a local API client for Kubernetes. What it's doing is just basically talking to the Kubernetes API. And so you can run a number of commands, and that will connect to the Kubernetes API and run things for you. So here, what I can do is say there's a number of very convenient commands. So you can say run something like Nginx with an image of Nginx, and I'll give it a version here. Equals 5. So here I'm going to run 5 instances of Nginx, and I'm going to use this image here that I've given it. And this is basically just a Docker image that it's on Docker Hub. So if I run this and the Wi-Fi is forgiving, then it should run or create a deployment for me for Nginx. And what I can do is, what that's going to do is create a deployment, which will then, that deployment is an object in Kubernetes that will then manage all of the instances of Nginx that I'm running in the cluster. So here, if I say get deployment, I should be able to see that I have Nginx running. This is an Nginx deployment. And then if I get pods are essentially a type of, or an abstraction that runs several containers together. So this is, but right now I'm just running one single container. But you can see here that I've got 5 instances of Nginx running right now. Okay, so that's great. I've got 5 instances running in a Kubernetes cluster. So if you want to check out the underlying hardware, we generally don't really care about the underlying hardware, but you can look at it by checking the nodes. See, I've got 3 nodes here that I'm deploying to. But essentially, when we're actually deploying applications, we don't care about these nodes. We don't really care about the actual instances that we're running on it. We're not SSHing into machines and running applications or installing applications. We're simply telling the cluster we want to run Nginx, and it's doing it for us. So now, what we want to do is we want to say, okay, how am I going to expose Nginx to my users? Because right now, what I've got Nginx instances running in the cluster, and they're running on some of these nodes, but we don't necessarily know which node it's running on. And those could change at any time if Nginx crashes or if one of the nodes goes down or whatever. So what we can do is we can say expose Nginx deployment, Nginx on port 80, and we'll give it this type load balancer. Sorry, that kind of wrapped a little bit, but if we give it this type load balancer, what Kubernetes can actually do is automate the creation of a load balancer for me. So what I'm doing is I'm running this on a cloud platform, so on a provider. So you can run this on like Google Cloud Platform, or you can run it on AWS or other cloud platforms that have load balancers. And it will create a load balancer for you as part of that, the automation that Kubernetes provides. So here what I've done is I've created something called a service, and that will, once the service is created, will then load balance the traffic to all of my Nginx instances that are in the deployment. So here I can say get service, and it'll take a bit for the external IP to come up once the load balancer is provisioned. But once we have that provisioned, we'll be able to actually connect to the Nginx service externally via a public IP. It also gives you a cluster IP internally that you can use to connect to the Nginx service from within the cluster as well. So now we have this external IP here. So now if I say curl HTTP, like that, we should be able to see that Nginx is running, okay? So if we say like Nginx version, we can see like that I'm running this, the version that I specified in the image, right? So one of the things that's really cool about Kubernetes is if we say like get deployment. So Kubernetes allows you to define these types of applications in a declarative way. So you basically tell the cluster what to do or what you want, and it will do it for you. So what that looks like is if we say get deployment and we say the output is YAML, we can actually look at what deployment looks like. We have the deployment, so you can see that this is a deployment object. So when you create deployments, you can create these manually, not using the rub command, using a create command. And you can specify a YAML file that looks very much like this in order to create these objects. But we can see that we have a deployment. Some of this is metadata that's kind of created automatically. But the important part is that you can see that we deployed 5 replicas. And we're using this image down here, this Nginx 1.10.1, right? But some of the other things that's really cool about deployments is you can run a rolling update to update applications, right? So let's say, could be control. You can say edit, deployment. So actually, let's do this. While true, do curl HTTP version. Let's make this silent. Then, oops, grep Nginx, and done, right? Hopefully. Well, let's just do this. This will tell us what the actually curl -s HTTP version. If we do this, it should give me Nginx. N-G-I-N-X. Yeah. So what was I doing wrong here? Something like that. Yeah, there we go. Let's actually sleep here for 0.5 seconds. So we can see we're actually running this. We're running this version of Nginx. So if we say, let's see, new window. Let's do Pro here. So if we do make this bigger, then we say edit deployment Nginx. And then we go down here, and all we have to do is change this image here. We're just going to change that to number 2, 10.1.1.2. And if we save that, the deployment will get edited. And then Kubernetes will know to actually start updating the application to the new version. So we should be able to see the new version coming up here. And it's actually downloading the image. But here we can see that now that it's downloaded the image, it's starting to update the instances. So you can see that we've actually done a rolling update of all of the pods, and we can see that they're all about several tens of seconds old. So that's great, but like that's just basically deploying applications, and that's really interesting. But what I want to do is to talk about how to build kind of automation tools. So from kind of a high level, like what I said is that Kubernetes is architected in a way that is very asynchronous and works in a way that that you basically save some sort of state or some sort of desired state in the system, and then Kubernetes kind of asynchronously will set that or make that into reality, right? So I wanted to deploy Nginx. I say, okay, here's my desired state. Kubernetes goes ahead and saves that, and then in the background kind of goes ahead and deploys those applications, right? So it has a number of components that allow you to do this. So from the API perspective, we have an API server, which is the master server. And then we have a XDD server. So XDD is basically a key value database or a key value data store that can kind of store the cluster state or the desired state that I want. And then we have a number of other components, such as the controllers and scheduler. So these are components that are doing things asynchronously, kind of in the background. And then based on the things that what the scheduler and the controllers do, the kubelet, the agent running on each of the individual nodes in the cluster, will actually start running the applications in the cluster. So from at a very high level, what we say when we create a deployment is the API we send a request to the API server to create the deployment. And what the API server does is it saves the data in XDD, and that's pretty much it. It doesn't really do much when we are actually sending it the request, right? It just creates the data in XDD, and then after that, you can like query the API to say, okay, give me all the deployments that are running, and it will be able to tell you, oh, here's the one for Nginx that I just created, right? So that's basically all it does in the very beginning. But then we have like these controller managers and schedulers in the background, right? So the controller manager, these controllers, and there's several controllers that are as part of the controller manager, and one of those is the deployment controller, and one is a replica set controller, and these actually go through and will scheduler will take the desired state and move towards actually deploying the application. So what happens is the deployment will then create a replica set, and the replica set is another type of object in Kubernetes to actually create a set of replicas or a set of containers or pods. And so the deployment will manage the replica set, and then the replica set controller will then create the pods that are necessary to get to deploy the number of pods that I said that I wanted. So I said I wanted 5. The replica set will then create 5 pods for me. And if, say, like one of those pods gets deleted or something happens, it will say, okay, there's one pod is missing, so I need to create that pod in order to get to 5, right? There's 4 right now, so I need 1 more to get to 5, right? And it'll continually check this. So when I've created that, the deployment will say, okay, there's an Nginx deployment, and I haven't created a replica set yet, so it creates a replica set. The replica set then says, okay, I need 5 pods, and I've got none running right now, so I need to create 5 pods. And then when pods are created, the scheduler will then go and pick up the unscheduled pods and then schedule those to each of the individual nodes. And then once you've done that, the kubelet will take those pods and actually run them and update them saying that they're running. So this is done as part of this kind of control loop. Each of these controllers is running in kind of a control loop where it says, okay, I want to observe the current state of the cluster and then diff that with the desired state, the state that I saved in XAD. So if I have my deployment will just check to see if I have a replica set running, and then if I don't, then it will create the replica set for me. And then it will observe the state again, and it'll say, okay, do I have a replica set running? Yes, I do. So it doesn't need to do anything. And then it'll continually check for this. And then the replica set, in turn, will have its own control loop that says how many pods are running, or how many pods are currently created in the cluster. And if it's like 0 or not 5, then it will diff between the current number and the number that you want, and then it will actually create the number that you want or remove some if it needs to. And then it will continually do this. And if it doesn't need to do anything, it won't do anything. But it's continually there watching and monitoring your applications to make sure they're running. So let's just go through kind of a step of like what's actually happened. So like when we created the deployment, we created our Nginx deployment. Here I actually have a different name for it. But so what I've done is I've created a new deployment. That deployment controller will see the new deployment, and it'll say, okay, I don't have a replica set created, so I created the replica set. The replica set controller will then see the replica set, and will say, okay, I don't have any pods created, so I need to create the pods. And then it will actually, once it's created the pods, these pods will then get picked up by the scheduler because this node name is null, or because they're unscheduled so far. And then the scheduler will then pick a node that has open resources that it can use to run that pod or to run those containers. And then once the kubelet sees that, it will update the status of that particular pod, and then tell Docker to actually run the pod. So here Docker will download from Docker Hub or from your private registry and actually run the container. And then the kubelet will then monitor that and see that it's running and update the status. So this is that's a pretty high-level view of like what actually kind of goes on within the cluster. But we noticed that like all of this stuff happens asynchronously. This isn't happening when we post the API. It happens all in the background. And there's a number of reasons why like things could fail or things could but in general, what happens is I create the API, I create the objects, and then Kubernetes kind of asynchronously in the background tries to go to the desired state. So in order to actually deploy applications that are so this is actually a very important concept, because we're going to do almost the exact same thing when we're creating our applications that are going to be deployed and automate things in the cluster. So we're going to actually do things that create these kind of applications that are architected in the same exact way as these deployment controllers and these schedulers and these types of applications. Like this is essentially like using kind of these distributed systems patterns in order to create these kind of automation tools. Like what we actually notice is that these deployment controllers and replica set, the deployment controller and replica set controllers and things like that are all components that are automating something for us, right? So when we've created our deployment objects, we're basically saying this is what I want, and then the Kubernetes is actually automating the deployment of these applications. And as I kind of showed you earlier, it also automates the rolling up the updates and things like that for these applications as well. So some of the things that you can kind of try to think about automating might be something like, a good example is, renewing SSH certs for an application, or kind of like if you have an SSH certificate and it kind of needs to be renewed, then you can kind of use automation tools to kind of renew those and redeploy them using something like Let's Encrypt or whatever. You can do a number of different types of things, but one of the things I'm going to use like kind of a simpler example of a password policy manager. So like say we have Kubernetes has something called secrets, which allow you to kind of store configuration that's like passwords or like tokens or things like that that can be used in your application. So like certificates or passwords or things like that. And so one of the things that you can do is maybe just as an example is to check those to make sure that the passwords are of a certain length. So in this case, we might have a loop here that checks the HTTP API to get the certificate or the secrets, and then kind of loop through all the secrets and check the secret data for a password and check to see that it's at least 10 characters big. And then if it isn't, then we can just go ahead and delete that secret because we don't want it in the system, right? So you could do any number of things, but essentially the idea is like that we're going to continually kind of check the application or check the state of the cluster and then move it to a desired state that we care about. So like in this case, we're going to move it to a desired state, which is that no secrets have less than 10 passwords or less than 10 characters in the password. So let's see what that looks like, right? Let's go ahead and delete our deployment for Nginx. One of the cool things about these kind of like automation tools as well is that like when you delete these deployments, these controllers will also act will also automate for you the deletion of these components as well. So it's like, hey, I don't want this Nginx running anymore. I can just straight up delete it. And then the controller will say, okay, I don't need this deployment anymore, so just delete all of the objects, and those controllers will then delete the pods and everything. Oops, not secret. Service. Okay. So what we want to do is we'll look at the application that I've got here. System controllers, source custom controller. So I've got like a little secret policy enforcer here, and this is has some code that's very similar to the code that I just showed you. But this is, I've written in this in Go, and essentially what we've got here is we've got a loop that's just going to continually loop, and we're going to like pause for 5 seconds in between each time that we actually hit the API, so we don't overwhelm the API. But we're just going to get the secrets. We're going to come down here, decode the JSON from the API. Then we're going to go through all of the items in the list, and we're going to decode the data, the base 64 data. We're going to read the password characters, and then we're going to check if it's less than min bytes, and if it is, I'm going to delete it. So then here we have this delete request to delete the secret that we just found. And that's pretty much all we're going to do. Down here we do the actual request, and that's it, right? And the min bytes right now here is 10. So we're going to say we need a password that's at least 10 characters big. Okay, and you can actually run these type of controllers like anywhere. They don't necessarily need to run in the cluster. They could be anywhere that that you have access to the API. And right now I have access to the API on my laptop, so I can actually just run this on my laptop, right? So go run main. So this is just going to compile and run this application right for me. I need to run kubeproxy. Let's clean this up a little bit. Proxy. And this is just going to proxy the API for me so that I don't have to worry about authentication. But then if I run this, it should be able to connect to the API and start running this this loop. And right now there's nothing kind of going on, so it's just going to kind of sit there. And let's clean this one up too. Clear. Now let's say create a secret. Let's just say test. And we're going to say from literal, and that's equal to password. What's a good password, guys? Password. That's a good one. So we're going to create this test one. Oh god, it's already deleted it. So here we've got, so this is going to check continually, like for new secrets, and then delete the ones that have too short of a password. So what's a better password? Password. That's a good one. This one's actually going to be long enough for us, but so we can see that like we're actually not going to do anything here because it's going to just it's going to check and make sure, see that the password is long enough, and then it's actually just going to ignore it, right? And then we can see if we create another one, say, okay, this time I'm going to ask you like for what's a good password. What's less than 10 characters? DevOps, that's a good one. DevOps. So then we've got a new one. Oh, and it's already deleted it again. So we can see that like as we have multiple secrets, it still is able to kind of handle that and only delete the ones that are less than 10 characters, right? And you could like expand on this. Like it doesn't have to be less than 10 characters. It could be less than like 15 or, you know, whatever. Or you could like check to see like that it has like special characters or numbers or that sort of thing. Or you could check it against the database or something like that, like of known words. And you don't necessarily have to delete it every time. You could like maybe send your administrator an email or something. You know, like any type of automation this way, like is the type of automation that I'm talking about. You don't necessarily have to do exactly what I'm doing, but you could do, you can think of anything that you really want to do and just kind of automate it using this, using code essentially, and that can check the API and check the state of the cluster. So another good example is, so say I want to like run things periodically. I want to run applications periodically. So Kubernetes, we could say like, let's run a job or run something every 5 minutes or every so often, right? So this is essentially kind of like cron, right? So we might have something like, we might have something like a cron tap object. Let's say we'll just pretend we have a cron tabbed object, and we'll just check for that cron tab object, and based on the objects in the, or based on these kind of cron tab objects that we've created in the cluster, we can then create these kind of scheduled jobs in the cluster. So so we'll say like if there's a new cron job, we'll like kind of add it to our internal registry, and then run that cron job every so often, however much that cron job says that we should run it. And then if, say, the cron tab object has changed, we can change it. Or if it's been deleted, we can stop our kind of cron tab loop, right? So I have an example. Let's see, what is it called? Cron tab. And what I have is this kind of simple cron tab controller, right? And this is very similar to the one that I just looked at, but this one's actually going to use not an existing object in Kubernetes. It's not going to use the secrets, which are a built-in object. It's going to use what's called a third-party object, or this is a kind of custom object that I can create. And this is great because this allows you to extend Kubernetes with objects that you define, and then use those as configuration for the type of automation that you want to do. So in my case, I'm going to use a third-party resource called a cron tab. Oops, this is the resource side. So this is a third-party resource. So when I use a third-party resource in Kubernetes, this is a special type of object that when I create this object, it creates me a kind of like a table. Kind of like, if you were thinking about like a database, this would basically create a table for me. So this creates me a new type of object. And then that new type of object can then I can create instances of that new type of object. So here I'm defining that I can create a new type of object called a cron tab. So here we can see that the cron tab, this is where it gets the name up here in this cron tab part. And then we can say like, put in here a domain which is kind of similar to like, example.com or whatever your website is. Maybe it's gojek.com or something like that. But and then we can actually specify like kind of multiple versions of our API as well. So what this will do is actually, once I've created this new type, Kubernetes will actually allow me it will create an endpoint in the API that will allow me to create objects and delete objects just like any other object in Kubernetes. So this is really, really powerful because it creates it extends the entire Kubernetes API. So once I've, created this, so here's how we can create an object from YAML with Kubernetes. We can use the create object or the create command. And this will create a new third-party resource, and we can say get third-party resource. And we can see my cron tab object here. And then we can say create new instances of that. So I have an example here of a hello world cron tab. And so what this is it says, it just gives me a name for my cron tab called hello world. And it gives me a cron spec, or I specify cron spec in here. And this is pretty much free-form JSON, so you can make this any type of object you want, or any type of structure that you want. It could be, have lists and objects and things like that in here as well. This is just a very simple example. But what we have here is we have a cron spec that will say run this every 5 minutes, and then a image that I'm specifying here. So this is just a Docker image that I can pull from Docker Hub. So here it's just a hello world image. So if you're a Docker person and you run hello world, you'll notice that Docker hello world will print out just kind of a hello world message for you, right? So I don't want to run this every 5 minutes because that would kind of take too long to. So let's just run this like every 1 minute or so. And then we'll say create f cron tab. And now I have my cron tab created. And this is, it's worth noting that this is not a basic or a built-in object, right? Like I mentioned, this is an object that I've created the third-party object or the third-party resource, and then I've created an instance of that third-party resource now. And what's really cool now is that things like get cron tab now work. So I can say get cron tab right from my kubectl command. So this is really, really convenient because I've now created my own cron tab type in Kubernetes, and I can then use that to define objects that that have my own kind of configuration in it. And then I can use that to create some automation that I want to do. So here I can say kubectl get cron tab, and then say the output is JSON, so we can look at what exact JSON is being stored. So here we can see that we're actually getting a list of objects. But here's my items, and in here we can see my cron tab object. It has the hello world image and this cron spec that I created. And then it's got the other kind of regular metadata that you have with all kind of Kubernetes objects. So like all Kubernetes objects kind of have things like a resource version, these links and the UID and stuff like that. So this is something that you kind of get for free when you use third-party objects. So let's look at what my cron tab or my cron tab controller looks like. So if we look at the main object, this one's a little bit longer, but I'm using a library called GoCron, I think it's called. So here we have this like cron library that I'm going to use. And so, and here's, I've defined some kind of endpoints. So these are the kind of endpoints that I can, that I'll use, but you can see here, this is the endpoint that I've created for my cron tab objects. So here, this API is stableexample.com. So this is the domain that I had set for my cron tabs. And then from there, I can actually just use, get the cron tab objects. So you can imagine that like maybe your organization has like a particular domain, you know, like devopdays.com, and you might have like a stable and a staging or a stable and a test, different domains like that. And then you can kind of use those domains, and then you can have like any number of objects perhaps inside of those domains, depending on like what sort of automation or what sort of things you want to do. So so now that we have that, we can say, go down here. I'm going to keep a list of cron servers, which are basically the objects for that API, and those are going to actually do the work of running some code whenever periodically based on the cron spec. And I'm going to save those based on the UID that I had for my object. So each of my objects will have a UID that I get for free from the Kubernetes API. Kubernetes just kind of creates those for me. And then that resource version tells me that that's the version of the object. So like when it changes, I can check the resource version to see if the resource version has changed. And then I can say, okay, well, this object has changed. Now I need to update the internal cron server to run instead of 5 minutes every 1 minute or something. So here, once I've done that, so I've defined like a bunch of these different objects, and then what I'm going to do is I'm going to sleep some poll interval, and I think a poll interval is kind of, what did I set the poll interval to? That's actually a default of 15 seconds, so we'll kind of change that. So what it does is it sleeps the poll interval, and then it does essentially a very similar thing, like it will do a get on the API. So it's just basically polling the API every so many seconds. It does some error checking, it decodes the JSON just like we did in the other one, and then it will run through all of the cron tab, the existing servers to see if any of them are updated or need to be removed. And then it will check go through all of the list of the objects to see if the objects need to be updated. So like actually this first loop was just to see if we needed to remove objects. So if any of them are missing, then we would need to remove the current ones. And then then we go through all the items that are existing and we say, do we need to update it? So like if the UID is the same, then we can assume that it's the same object. And then we can say, if the resource version is changed, then we'll actually update it. So we'll just remove the cron tab and add a new one. Or add it, and basically add a new one. And if we have one that's not found, then we'll just add it, we'll create it new. And that's pretty much it. Like down here, we're actually doing the work of creating the cron server. So here we're saving them based on the UID, and we're giving it a start. And when we remove cron tabs, we stop the cron tab server, and we remove it from our cron servers list. And then every, so often, based on the cron spec that I've created, I'm going to actually just run what's called a job in Kubernetes. So Kubernetes has, like I mentioned, these deployment objects, which will create things like, are great for running things like web servers that run things over and over again, or keep things running all the time. But what if we want to have some batch objects? So in this case, we're actually running a cron job. So that's like a batch. So what I want to do is I wanted to run something just once and then have it kind of finish. You know, it will, if it finishes, I don't need Kubernetes to restart it. I just want it to like kind of finish and make sure that it finishes. And if it crashes halfway in between, Kubernetes can restart it for me. But once it's actually finished successfully, I don't want Kubernetes to do anything. I just want it to finish like successfully, right? So in that case, what I can do is I can make something called a job. And in Kubernetes will check to make sure that that finishes with a good exit code. But if it kind of crashes in between with a different exit code, it will figure out, oh, okay, I need to restart this job, or I need to rerun it. So what I'm going to do is I'm going to make up a job name for it based on the cron tab name, and then I'm going to create a job object. So here I'm just creating an object that I can write to JSON, and then I'm going to JSON write that, create the JSON for that, and then post that to the API. So here we can see I'm posting to the JSON API. And just making sure that it's created. And the interesting bits here are basically that we have a job spec, and we have kind of a job template here, which is going to tell us which containers we want to run here. So here we can say, here's the image that I'm going to pass. So this is coming straight from my cron tab object, and we're going to give it just a simple name, and we're going to say we don't really need to restart this. We're just going to let this run, and when it's successfully completed, we're just going to let it go. So in this case, actually, we're going to say never, because so this means actually if there's an error, it's actually not going to restart my job for me. It's just going to let it go. So this is I'm just kind of assuming that I'm going to run this every so often, and if it fails, then I can the next cron is going to run it again in the next period, and everything will be okay. So that's just this one. You could change this restart policy to make sure that it actually restarts the job if you care about that. But essentially, that's how it's going to work. So if we actually drop out of this, we could say, or actually, let's just run this. So say, not kube control, but go run main. Let's look at the help, actually. No. 250. Some live debugging here. Map, string, labels. Do I need this? Maybe not. I actually have a version of this already built and running, but let's just use that. So I can actually just deploy this into the cluster. So I have one here. Ultimate Hydra is my cluster. So if I say config list, yeah. So create. So I'm actually just going to deploy a pre-built version that I have in the cluster. So this is pretty cool because what I can do is I can actually just use kubecontrol to kind of proxy to the API and handle the authentication for me, kind of like I did locally. And this is like one of the powerful things about pods. Pods are a collection of containers that run together. And these are always going to be scheduled on the same exact machine. So what this allows me to do is like each pod will have its own IP and these containers are run together. So they can actually talk to each other over localhost. So when I run this kubecontrol proxy, it will actually, I can actually connect to it from localhost from my cron tab controller, just like I would locally on my own machine. But I don't actually have to build any of that into my images. Like my cron tab controller can just talk to localhost and not have to worry about the orchestration or actually running of kubecontrol and things like that. So no like crazy init scripts or entry point scripts like you do in Docker to actually create both of these containers. No running like things like Foreman or like supervisor D inside of your containers, because Kubernetes kind of handles that for you. And if either of these containers crashes, Kubernetes will kind of restart them for me. So if we look in the cluster, we should see this guy. The image is not there. Let me see. Some more live debugging. Failed to start. I know what happened. I'm deploying using somebody else's image, and they've deleted the image from Docker Hub. So what I'm going to do is I'm going to find the right version, because this guy has deleted his image from Docker Hub, and that's not cool. Don't do this, by the way, guys, because you will have a lot of people who have to live debug their applications because some guy deleted from Docker Hub. Oh, come on. I'm just going to give it the latest version of Kubernetes, which is 1.4.5, and see if that works. So kubecontrol apply is how you actually update an existing object in Kubernetes. So this is how I can update my deployment with our new cron tab controller. So like all I did was I updated the YAML file. So image to 1.4.5 here. So I updated this version, and hopefully it will deploy the new version and it will be running. Oh, and it's running. And so it looks like it's actually created my first job for me already, and it's running running one of the pods as part of my job. So here, if I say simple cron tab controller, if I take the name of this and I say logs, I can actually pull the Docker logs. So this is like something that Kubernetes does really well for me. Oh, come on. Yes. I have to pick which container inside the pod that I want to use. So cron tab controller. And this will tell me that it's watching for cron tab objects. It can now, as it's starting up, it can't connect to the API, but it eventually will be once the, and then here it's actually created it's found a cron tab and it's creating it. And then it created a job for me. So if I say kubecontrol get jobs, hopefully I'll see my existing jobs. So we have 2 that have run so far in the last couple minutes, and they've both run successfully. And we can say get pods, but these won't actually show up because they're already done. Okay, so yeah, it says 2 completed objects were not shown in the pods list. So I can say show all. This is really friendly, isn't it? And if I say get pods show all, we can see my completed pods here for my job, right? And if we say, okay, let's look at what happened with this guy, we can say logs. We can actually see that this is a hello message from Docker, and it shows that, you know, Docker is working right and all that stuff. So we can see that the jobs are actually getting created periodically here, one every minute or so, based on, you know, for my controller, based on my what my controller is doing. And so this is like a really kind of powerful example, but you know, this is commonplace enough that the Kubernetes actually is going to have or actually has now a native scheduled jobs object, which is alpha in 1.4. But this is like kind of a decent example of how to actually, you know, automate some sort of tasks that you want to do. So basically, what you would do is you kind of like, you know, poll the API per what I've done before, and then like you can update the internal kind of state of the cluster to what you want, or update the internal state and do things that you want to do. So this might be something like you might have your own kind of controllers to create things like load balancers, or you might have your own controllers to kind of set up different types of things, or enforce policy, or that sort of thing. So this is pretty much what I wanted to show. I think that's about it. So I think that's pretty much everything that I wanted to show in terms of in terms of like how to create these kind of distributed systems that will allow you to kind of automate things, or automate your DevOps workflows and things like that in this kind of new world where we're actually deploying containers and deploying applications to a container orchestration system. So things like that you might have written in bash scripts or might have written in some kind of like one-off applications can actually be written now in things like Go or in things like Python or whatever language that you care about to interact with the Kubernetes API in these type of controllers that run in the cluster and kind of do things, do this kind of automation or do work for you asynchronously. So that's kind of like the overall image of like how things will work in this new world when you're actually running containers. So thanks a lot for having me, and I hope that was really helpful. I do have like about 5 minutes or so if anybody if anybody has any questions, or do you guys have like a mic or something? Yeah.
Hi, I have a question about the third-party resource. Right at the back.
You're in the back. Okay, there you are. All right.
So I think third-party resources are super powerful, but can you write the controllers for them only in Go or in some other language as well?
Oh, you can use other languages as well. Like anything that can interact with the API. The API is basically just a JSON API.
Sure.
So there are a number of kind of like control clients out there, API clients, for things like Python, and I think there's a couple of them for like Ruby and stuff like that. They're in different levels of development, like in terms of what they support. Yeah, you can write your own API client or just talk to the API using JSON or whatever. Cool. So any language is good.
Okay, thanks.
Yep. Yeah, Go is just a really easy language to do things like this because of its kind of asynchronous, its ability to do kind of asynchronous work. That's why I chose it.
Okay, so the question is really, do you require a monitoring system on apart from what Kubernetes can give, or do you need can Kubernetes solve all your monitoring needs? in production?
So you will need things like extra kind of things like monitoring, depending on what you need to monitor. So Kubernetes can do things like monitor the application state, like whether it's running, whether it's crashing, that sort of thing, and then restart it for you. It also has like some somewhat limited abilities to do things like measure resource usage. So say like your application is using X megabytes of memory or X gigabytes of memory and is using so much CPU. It can monitor those things, and it has built-in kind of tools to do that. So you can get that kind of information, but right now, like if you need things that are more internal to the application, like things like what's the latency of the requests that are coming into my web server, or how much time is it taking when I do a database SQL query or whatever. Like those types of things, you're going to need some other kind of monitoring tool for that. So something like like Datadog or like New Relic or something like that can really help you in those type of situations. Yeah, so that's essentially what type of monitoring you might need depending on your needs.
Okay, and the second thing is Mesos and Kubernetes. Seem to be a lot of overlap between them. So where do you see them going in the terms of roadmap? Are they going to converge? Are they going to complement each other?
Yeah, I don't really know a whole lot about Mesos myself, but as far as like from what I've seen, is Mesos has like kind of is like only kind of one level of what you want to do. So it's just really a kernel that kind of is able to schedule jobs for you, and so what you need to do is you actually have to have like these Mesos, what do they call them? Not platforms, not plugins, but the frameworks that you have to have on top of Mesos. So like things like for MapReduce or I think what was it called? So like there's those type of like frameworks that you have to build on top, and so Kubernetes like kind of does a little bit, kind of has a lot of that stuff built in, and it kind of mainly focuses on things that need to be running all the time, and then kind of batch jobs, and so in general we think that like that model is enough for the kernel, and you don't necessarily need to have this kind of frameworks type of style, but definitely like things like like these different frameworks can actually like run Kubernetes as a part of a framework inside of Mesos, and so like there is some kind of overlap or ability to work together, but I think that in general like you could probably choose one or the other depending on what you want to do. Any other questions? I'll take one more. Nobody.
Can you touch upon the persistent storage associated with Kubernetes?
Okay.
Okay, that's better. Can you touch upon the persistent storage story behind it? I don't really get a lot of material on it on the.
Okay, so persistent storage the question is persistent storage. So I assume you mean things like databases and like file storage and things like that. Like, what are you specifically talking about?
So anything that we can associate with the container. So even if the container dies, I can use the same persistent storage to bring up another container.
Okay.
With an application.
So Kubernetes has the most basic way to store data is to use what's called persistent volumes in Kubernetes. And so what you can do is you can say, this volume I want to attach to these type of containers. And then what that will allow you to do is mount a volume inside of the container, which you can use to store data. And usually what this is like some sort of like network attached storage or storage that is outside the cluster. So like you have maybe a network attached storage that uses iSCSI or something like NFS or something like that. So Kubernetes supports those. It also supports, if you're in a cloud environment like AWS or GCP, it supports the native persistent disks there. So persistent disks on GCP, Google Cloud, or Elastic Block Storage on AWS. And so that's the basic way. So you can kind of mount these containers inside, or mount volumes inside of a container, and then write data to those volumes. You can, and then there's another way like called volume claims, which allows you to say like you have a deployment which has many different containers inside of it, and it can kind of scale. If you have, say, if you have that, you can create these volume claims, which give you basically a policy to say like, I want these type of disks to be mounted inside of these containers, which allows you to like kind of be a little bit more flexible about how you create the volumes or how you mount the volumes. And the volume claims in a cloud environment can actually be used to like create automatically the disks. So like if you create a volume claim in Google Cloud or in AWS, you can then have it create a matching volume in the cloud environment, and then be able to attach that. So there's that, and then for things that really need to have a little bit of hand-holding, that can't be necessarily like, that need need a persistent host name, something like Riak or some sort of the database that has to have like, this is my host 1, host 2, host 3, and it has to have a name in order to like join the cluster. You can use things like what's called a pet set in Kubernetes, which is similar kind of to a deployment in that like you can create a volume, or it will attach a single volume to each host. So like say you have, it will give you a persistent name. So like this is my host 1 or of my Riak cluster, and then that will mount a specific volume for host 1 to that container, and then run it. But you don't get the same sort of things that you would get out of a deployment where like if that particular node goes down, it won't be able to automatically recreate it somewhere else. Like it can kind of try to restart it, but it won't. If like say the entire node or the entire physical machine goes down, it won't be able to move it to somewhere else safely. So it needs a little bit more intervention, or it needs a little bit more kind of monitoring there and human intervention. So there are those type of features as well that will help you a lot, to deploy those type of stateful applications.
Thank you.
Okay, I think that's enough questions, or I think I'm out of time. So thanks a lot for having me, and I hope that was really helpful. I'll be here around the conference for the next day, or next couple of days, so if you have any questions, feel free to flag me down, and if you think of anything. Yeah, so thanks a lot.